Alright, hello everyone. This particular podcast we are now going to be solving linear systems using elimination. I'll have to admit, of all the ones that we do, this is the one that I use most often um, because it's just easiest to do and most problems are already set up for that. Oh, let's add in a new page. There we go. So let's go ahead and begin there. And this is solving systems using elimination. And again, I use this one more than I use any other because most problems are set up for this because they're usually in standard form. So we'll start. And so what you're looking at, the word elimination basically tells you what you're doing. You are eliminating one of the variables. So what you're looking for is two equations where the variables are the same coefficients. One is positive, one is negative. And then we'll move into what happens when it's not because you can change them. And so for example 1, and again these are all solved, we're still writing as ordered pair. So if we have x minus y equals 1, and then we have x plus y equals 3, we're basically going to add the two equations. So x plus x is a 2x, the y's fall out, and we get 4. Divide by 2, so x equals 2. Now you take this, plug it back into one of them, and you're done. Again, this is why I said this is the easiest one, especially when it's already set up. So I'm going to use the first one. So I have x minus y equals 1. So I have 2 minus y equals 1. Subtract 2 from both sides. And we're going to get negative y equals negative 1. I need y, so multiply through by a negative 1 or divide by negative 1. I don't care which one you do. It does the same thing. So then y is a positive 1. So your ordered pair is 2, 1. Okay, so that's pretty easy when they're already set up for that. Let's do something where you have to do a little more work. So let's do another example. And so this is example 2. Now for this one we're going to do 3x plus 4y equals 19. And then we're going to do 3x plus 6y equals 33. Now notice these are exactly the same except for the x's, except both positive. So we need to change one of them so they're negative. So I'm going to multiply this entire first equation by negative 1. When I do that, I get negative 3x minus 4y equals negative 19. I just did that because the bigger numbers were on the bottom. And then I'm going to rewrite the second one. So again, they were the same except for the signs on the x, so I multiplied the first one by a negative, wrote it down, so I changed all the signs, and then I rewrote the second one, and now I'm just going to add them. Because what happens is the x's are going to fall out, and this is going to leave you with 2y, and then you're going to have 33 minus 19, or negative 19 plus 33, however you want to say it, you're going to get the same thing. It's going to be a positive 14, okay? And so I'm going to write 14. We're going to divide both sides by 2, so y equals 7. Now all we need to do is I want to substitute this back into the original equation. I always go with whichever one has the smaller numbers because it's the least amount of work. So I'm going to use 3x plus 4y equals 19. I'm going to have 3x plus 14 times 7 equals 19. So 3x plus, and I'll be honest, I don't know that. So 14 times 7, 98, equals 19. I'm now going to subtract 98 from both sides. So I'm going to have 3x equals 19 minus 98. I'm going to get a negative 79. Now divide both sides by 3. Ooh, and I got a fraction. Let's make sure I did my math right. And guys, there's nothing wrong with that. There is nothing wrong with that. But I just want to make sure. So I got y is 7. And oh, I changed it from 4 to 14. There's the error right there. So let's go back, and there you go. That's why you always go back and double check, because you just never know. And so see, I make these kind of mistakes all the time. Plus 28 equals 19. And the reason I double checked it is because I didn't get a fraction here. Generally, if you get a fraction on one of them, you get a fraction on both of them. But it's possible to only get it on one. So now let's subtract 28. And it was possible, but I just thought let's go back and double check anyway. So let's do 19 minus 28. And that should be a negative 9. So we'll divide both sides by 3. And you get x equals negative 3. Okay? And so your ordered pair is going to be negative 3, 7. Okay? Now, on your next slide, we're going to do exactly the same thing, except now we're going to do it where we have to make a little more of an adjustment. All right? Let's see. Oh, those are already set up the same. And we will be doing some word problems in here. Okay, so now we just did it where we just basically added both equations. And I always add, I never say subtract, I always add both. So now let's do some multiplication. And so this would be example 3. And the ones I want to do here is they're not quite the same, so I need to make them the same. So we're going to start off really simple. Alright, now notice I can either change my x or my y, doesn't matter. I generally try to find the variable where one is already positive, one is negative, that way it's a simple change. So notice the y is a positive 1, but this y is a negative 2. So if I multiply this entire first equation, by 2, I'll get what I want. So that's going to give me a 2x, this just means this is the next step. 2x plus 2y equals negative 18. And then this is 5x minus 2y equals 32. Now I'm just going to add them, which is what I've been doing. So I added in one more thing. I always put this addition sign in parentheses because it's my operation, so that way you know it's not part of the problem. So when I do this, 2x plus 5x is going to give me 7x. This is 0. And then negative 18 plus 32, it's going to give me 14. Divide both sides by 7. And so x is 2. And then once I have that, I'm going to go back to my original equation before I changed it. And so I'm going to use x plus y equals negative 9. Alright. And so that's going to give me 2 plus y equals negative 9. Subtract 2 from both sides. And so y is negative 11, so it's 2, negative 11. And again, you can check these just by substituting in them both and making sure they both come up, that they work. And so this really is all that's different. Let's try another one where we change another number, okay? And hopefully this is coming back to you from doing this in Algebra 1, because this is where you would have done it. Let's do this one. So we have 2x minus 3y equals 21. And then you have 5x minus 2y equals 25. Decide if you want to change x or y. Both x's are different and positive. Both y's are different and positive. So one of them you've got to multiply by negative something. So let's get rid of our y's. I'm going to multiply this one by a negative 2 and this one by a positive 3. Okay, and the reason they're not the same sign is because I need one of them to go away. So the first equation, I'm going to have a negative 4x plus 6y equals negative 42. And the second one, I'm going to have 15x minus 6y, that's an x, sorry, equals 75. Now let's add these together. Yeah, and I know it's amazing how it gets crooked really fast. So it's 11x. This falls out, equals negative 42 plus 75. And that should be a 33. Divide both sides by 11. And so x is 3. So notice what you see here is I had to do something to both equations in order to make them work. Let's go back to the first one. Numbers are smaller, so I want to work with that. And so I have 2x minus 3y equals 21. And I always go back before I changed it. Alright. So then 2 times 3 minus 3y equals 21. So we have 6 minus 3y equals 21. Minus 6 minus 6. I'm going to go over here so you can see it. So negative 3y equals 15. Divide both sides by negative 3. Y equals negative 5. So my ordered pair is 3, negative 5. So now as I look at these pages, I'm going to be looking for the ordered pair as the answer. I'm going to look at the work too, but I need the ordered pair as the answer because that makes it easier for me to check and for you to check. Alright, and so from here you're going to go on and then you will just tackle the next part. After this one we will be moving on to I think it's doing some word problems, some application type of situations where you actually write your own word problems, and then we will be doing graphing linear inequalities and solving linear inequalities, and then solving systems of linear inequalities. That's where the shading goes into. So we will see you on the next one.